Hello, and welcome to the DE 24/7 podcast. This is Brian Albright. I'm here today with Danilo Di Stefano, who's the product manager of Mode Frontier at ESTECO. Welcome to the program, Danilo. How are you doing today?
Oh, I'm doing well, thank you.
Good,
Everything is
very
okay.
good.
And you?
Very good. Well, we're here today to talk a little bit about some of the platforms you guys offer. To start off, could you tell me, what are some of the key operational challenges that are leading organizations to use solutions like Volta and Mode Frontier, the platforms that you offer?
Let me say that our Volta and Mode Frontier solutions take existing models, simulation models or data models, and transform them into some actionable ones, actionable models, basically providing our customers with a highly efficient design space exploration. Both Mode Frontier and Volta use process automation and optimization-driven design technologies to automate every sort of simulation process using any solvers that you may have to help at the end picking up the right design. Volta and Mode Frontier also both provide powerful graphical workflows to automate simulation, where you can integrate any tool from the simple to the very complex, and also to automate the entire design process at the end. This is what we call optimization-driven design, and definitely it brings many benefits. At first, it reduces the operational costs by removing complex simulation chains from the workflow, increased performance, and also competitive edge by evaluating thousands of designs simultaneously. And of course, also time savings across the entire design process by automatically running repetitive simulations. As a result, our customers can use our full suite of optimization algorithms to pick the right design to be increasingly competitive in the market and definitely to deliver better products in less time.
Why is this type of process optimization or automation becoming so important now?
But digitization of products and production processes is opening the doors of innovation for many organizations for the provision of technology-driven ways of working, let me say. Within the world of simulation, automation is a leading digital technology because it is very efficient in addressing the challenges that today's users face in the simulation space, while also at the same time accelerating and also democratizing every step in the design process. The design process itself is always more and more effectively tied with the entire product lifecycle management, helping to develop a kind of more holistic view on the entire process of the product life. Based on that, simulation is spreading its value across many stages of the product lifecycle, no more only in the conceptual design phase. This is also related to the product data that are becoming more and more available at various stages of the product lifecycle itself. And to be able to model this holistic view of the entire process, there is the need of new modeling formalisms that scales up to a more general business level, let me say. And also the modeling and automation capabilities that are traditionally available at the design level should scale up at this new, let me say, business level. This is why we believe that the business process management can effectively be used, can effectively complement the simulation process management to deliver a more complete approach to the product and process optimization at the same time. In this way, not only design alternatives can be explored in the design phase, but also many aspects coming from other phases in the product, in the process and in the product life cycle can be integrated in the exploration.
Well, can you provide maybe a few examples of how your platforms have helped customers solve these types of engineering problems? And you can be as general or as specific as you want.
Generally speaking, Volta and Mode Frontier are very versatile products. They can be used successfully in many different contexts and in different market disciplines. As an example, in the automotive field, they are mostly appreciated for their excellent capability for integrating with multiple 1D models and for their post-processing tools. Mode Frontier helps linking those 1D models more efficiently, supporting also a faster improvement of critical design goals by its effective optimization strategies. At the same time, Volta maintains concurrent use by different analysts in different locations, so delivering an effective collaborative approach to the design process. In the aerospace field, as another example, Mode Frontier and Volta are mostly appreciated for their multidisciplinary design optimization capabilities. The capability of Mode Frontier workflow to easily manage different disciplines in the same design optimization context when it is coupled with the Volta distributed execution capabilities. Together they are able to support our aerospace customers for effective optimization on design goals deriving from the needs of many different disciplines at the same time. Talking about a specific use case, just as an example, this comes from the manufacturing field, where Mode Frontier was utilized to improve the performance of a blast furnace in a plant in Trieste, in Italy. The problem was that uneven material distribution inside the furnace top-loading hopper was reducing the efficiency of the cast iron process because the layers in the furnace were not uniform. To overcome this issue, Mode Frontier was coupled with a particle simulation software to understand the material's behavior and to optimize at the end the design of the hopper's deflector. And thanks to Mode Frontier, the plant's engineer could evaluate more than, 1,000 designs in just a few weeks, evaluate in a deep way without having to set any parameters. The entire project provided definitely remarkable time savings, where Mode Frontier saved approximately 100 hours of computational time. And also human time savings were also significant. Without Mode Frontier, at the end, engineers would have had to manually change the geometry of the deflector for every simulation, at the end wasting significant amounts of time. By automating the process, the design engineers could launch the optimization stage with ease and avoid the process of manually combining the output from multiple applications. And this allowed them to seamlessly compare and to also validate different design solutions, while at the same time accessing key performance metrics to help them to boost the performance of the whole plant.
That's impressive. Do you think as we're moving into 2021 that there are particular features or functions in these type of platforms that are going to be more important to end users kind of heading into the next year?
Yes, I think that usability in general is a key issue for many working with automated solutions. And regardless also of their level of expertise, the individuals, the engineers are faced with complex algorithms and must identify the right optimization strategy to get the best results, while taking into account also the resources that are available to them. Such a kind of manual tasks are not only definitely time consuming, but also highly repetitive, where the design and engineering expertise of specialists at the end is not used to its full potential. As a result, organizations could lose its competitive edge and also ability to innovate. So while we continue to improve on state-of-the-art optimization algorithms for Baltimore Frontier, we also wanted to provide a more autonomous approach for non-expert users or those experts who just want to quickly test an idea. To achieve this goal, we initially introduced the self-initializing mode for our optimization algorithms. Using this technique, the user simply set a single parameter, the number of evaluations, and the algorithms then analyze the problem, automatically generating the most suitable design of experiments and searching for optimal solution. This is our first level of making it easier to access optimization strategies in Frontier and Volta. After that, we also introduced the autonomous optimization mode that takes things one step further, let me say. This is an intelligent solution which allows users to balance the time it takes to find the optimal solution with the number of design iterations that are needed to reach it. More than this, it is suitable for expert and non-expert users at the same time. The algorithms that are available in autonomous optimization mode use information that is collected from the problem analysis at the runtime stage to drive the optimization in the right direction. And they stop only when there are no further improvements easily available, altogether in a framework of a reasonable period of time. So at the end, optimization, the autonomous optimization mode requires no parameters at all to seek the optimal solutions, while minimizing the number of iterations that are required. Users simply need to press the play button to start the system working, and they have to wait for the results.
All right, well, great. That's all the questions I had today. Thank you for joining us.
Thank you. Thank you for your time. Bye.